Hello everyone. Today we are here to present our topic random variables, a discrete and continuous variables that represent a numerical outcomes. I am Arpita Wankhade and my teammate Damini Thakur, and this presentation is guided by our mentor Dr. Dipti Patil ma'am. Now, as we know that in data science we often deal with uncertainty and randomness. For example, predicting stock prices, analyzing customer behavior, or forecasting weather. To model such uncertain situation mathematically, we use the concept of random variables. In this presentation, we will understand first what random variables are, second, type of random variables, third, their role in data science pipeline, fourth, a solved example, fifth, and their real life applications. Next is, what is random variable? A random variable is a numerical value that represents the outcome of random process or experiment. For example, tossing a coin. The outcome can be head or tail. Second is rolling a dice. The outcome can be 1 to 6. We assign numbers to these outcomes. Head is equals to 1, whereas tail is equals to 0. And dice values can be 1, 2, 3, 4, 5, and 6. So a random variable converts outcomes into numbers. It is usually denoted by capital letters like X, Y, or Z. Next is type of random variables. Random variables are mainly of two types. First is discrete random variable and second is continuous random variable. First is discrete random variables. A discrete random variables takes countable values. Example, number of students in a class, number of heads when tossing a 3 coins, and number of defective items in the match. These values are usually finite or countably infinite. Example, if we toss coin 3 times, the possible numbers of heads are 0, 1, 2 or 3. So, x is equals to number of heads, that is discrete variable. We use probability mass function, that is PMF, for discrete variables. The second one is continuous random variable. A continuous random variables takes infinite values within a range. Example, height of a person, weight, temperature, and time. These values can be decimal or fractional. Example, height can be 150.2 cm, 150.23 cm, etc. We use probability density function, that is PDF. Probability is calculated over an initial interval. Next is difference between discrete and continuous. In discrete, first difference is countable values, and in continuous it is infinite values. In discrete, the examples is number of students. In continuous, the example is height, weight. Discrete use PMF, whereas continuous use PDF. Next part is the role of data science pipeline. Random variables play an important role in a data science pipeline. Data collection is the first one. Data collected can be discrete or continuous. Example, age is continuous and number of purchases is discrete. Second one is a data analysis. We use probability distribution to understand the data. Example, discrete having binomial or Poisson. And second one is a continuous, that is normal distribution. Third one is model building. Machine learning models use random variables to represent uncertainty. Example, predicting customer churn probability. Second is predicting rainfall. Fourth one is a decision making, helps in making data driven decision using probability. Random variables help convert real world uncertainty to mathematical models. Let's solve the example. Let us consider a simple example of tossing a coin twice. A defined random variable x is equal to number of heads. The possible outcomes can be head head, that is 2 head, head tail, that is 1 head, tail head, that is 1 head, and tail tail, which is a 0 heads. So values of x are 0, 1 or 2. So according to the probability distribution, having the value of x as a 0, probability is 1 by 4. Value of x is equals to 1, probability is 2 by 4. And the value is equal to 2, the probability is 1 by 4 again. So the expected value, we have the formula E of x, that is expected value is equal to summation of value of x into probability of x. Whereas when we multiply all this and take the summation of all numbers, we get the number 1. So the expected number of heads is 1. This is the example of a discrete random variables. Next one is application in data science. The random variables are widely used in real world data science application. First one is machine learning, used in probabilistic models like naive Bayes. Second one is risk analysis, used in a finance to predict stock market risk. Third one is healthcare, predicting disease probability. Fourth one is recommendation system, predicting user preference. Fifth one is A/B testing, that is testing product features using probability. All these are helped to handle the uncertainty and make a prediction. Last, conclusion. To conclude, a random variable are essential concept in statistics and data science. They help us to convert a random event into a numerical values, making it easier to analyze and model data. We studied first discrete and continuous random variables, second is their difference, third their role in data science, fourth is practical application. Understanding the random variables help us build better predictive models and make data-driven decisions. Before we could conclude, let us imagine a simple situation. Every day, we make our decisions without knowing the exact outcomes. For example, will it rain today? Will a product become successful? Will a customer return again? All these questions involve uncertainty. Now, think about how data science answers these questions. It does not guess. Instead, it uses probability, and the art of approach lies the concept of random variables. Random variable acts as a bridge between real world uncertainty and mathematical understanding. They help us convert unpredictable events into numerical values, which we analyze and interpret. Discrete random variables help us when we deal with counts like number of customers or number of clicks. Continuous random variables help us when we deal with the measurements like time, temperature, and weight. Together, they allow us to describe data more accurately and build intelligent models that predict the outcome. In today's world, where data is everywhere, understanding randomness is not just important, it is essential. For a machine learning models to artificial intelligence systems, everything relies on handling uncertainty effectively. So, random variables are not just a theoretical concept, they are the powerful tool that help us make better decisions, reduce risk, and create smarter solutions. As a future data scientist, learning these concepts help us understand how data behaves and how we can use it to solve a real world problem. With this, we conclude our presentation. Thank you for your time.